So let's look at part E here. So remember, in order to have a tangent line, the function has to be continuous. Well, there's an asymptote here on f of x, so that means there must be an asymptote here because there's no tangent line that can be drawn at x equals 0 because there's no graph. So now let's look at some slopes. So if I was to draw a tangent line at this x value, I can see it's a positive slope, right? And then if I do this one, that's getting to be a bigger positive slope, and then I'm doing the asymptote thing. So whenever we're approaching an asymptote, it does the asymptote thing, right? So it's going to be some small positive number and then go up to some big positive number. Okay, so then we come after x equals 0, and the first tangent line I draw is a large positive number. And then it gets to a smaller positive number, but it always stays a positive slope. So large positive number near an asymptote means it's up here, and then it comes down like that. Okay, so let's try this one. Again, it has to be an asymptote on the derivative graph because there's no graph at x equals 0. It has to be continuous in order to have a slope of a tangent line. So when I start drawing a tangent line, it looks a little bit negative, big negative, huge negative, a little bit negative, big negative, huge negative. Then when I jump back on the graph, it's big positive, and then it gets smaller positive, but always stays positive. So huge positive near an asymptote means it's coming from here. Well, this one has a little bit of everything. So I can see I'm going to have asymptotes here and here. And I can see that the slope of the tangent line right there is 0. So I'm going to have 0. So let's just go from here. So small positive, big positive, huge positive slope. So it goes up like that. Huge positive, smaller positive, getting to 0. So huge positive from an asymptote means you're coming down, and I'm getting to that 0 point. And then after the x equals 0, here's small positive, big positive, huge positive. Again, it's doing the asymptote thing. And then here, if I jump on the graph right after the asymptote, it's huge positive. So huge positive near an asymptote means it's looking like that. All right, so we've kind of already seen this, but let's go over it again. If we see a corner on the function, that means it's a hole on the derivative graph. So these were all the same slope of -1, and these are all the same positive slope of 1. There it is, that graph. So here we have lots of things. Okay, so again, because we see there's a hole, it's not defined, right? It's not continuous. I'm going to have a hole there. And then let me figure out where the hole is going to be, but I know it's going to be a hole. Then here I know is going to be a hole, and here is going to be a hole because those are all corners. So corners come off of straight graphs. So if I was, so here and here, so just kind of making it, so it's kind of, that's, I'm trying to show, it's helpful to have it right up below. All right, slope of the tangent line here is 0, 0, 0, open circle, 0, 0, 0, 0, all the way to this corner, open circle. Okay, so then here it's some positive slope. So I'm just going to choose that and then open circle. And then here it's going to be some negative slope. So that's going to be something down here and goes on forever. Okay, so let's get to the other challenging ones. If it's a cusp on the function, remember that I called this a cusp, then there's going to be a vertical asymptote on the derivative because the derivative doesn't exist at a cusp. So let's look at this. So it's going to be up, positive, 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 huge positive to doesn't exist. Huge positive to doesn't exist. And then if I jump back on the graph, it's huge negative. So it does the asymptote thing. So it's coming from down there. So again, this is a cusp. So it's going to be a vertical tangent. I see the slope of the tangent line is 0 here and it's 0 here. So let's jump on the graph. Big negatives, bigger negative. So this is negative and then going to huge negative. Then if I jump back on the graph, it's huge positive until I get to 0. Huge positive from an asymptote means coming down like that. And there's my 0. And then if I jump on the graph after the 0, I see that's a negative slope until I get to this 0. So below the x-axis. So below the x-axis just means negative slope. And then here, positive slope. So it's going up like that. All right. If it's a vertical tangent, I'm trying to draw them like really significant so you can see it, that translates to a vertical asymptote on the derivative graph. So if I'm coming in here, positive, positive, bigger positive, so it comes up like that. I see that this is, I tried to make it like a 0. So it's still positive, 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 and coming off of an asymptote, it's coming from the asymptote, right, to the 0, and then it just goes negative slope forever, and it doesn't matter the shape. This one here is also a vertical asymptote. So negative, 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 going to doing the asymptote thing. And then after the asymptote, it's still negative until we get to 0. So asymptote thing to get to 0, all of this is negative slope down here, right? And then it's positive slope. When we have an end point, there's not one tangent line, because we can draw all kinds of them there, right? So we say that it's not differentiable. So if I was to draw a tangent line there, that would be huge positive, smaller positive, right? So it's always positive coming from huge positive. So there it is. So at the end point, we've got the vertical asymptote. So this one here, I'm going to have 2 vertical asymptotes because there's 2 endpoints. So this one here, if I drew a tangent line, again, you read a graph like you read a word, big positive, so big positive, getting to 0, right? Getting to 0. And then after that is negative, negative, negative to huge negative, so it looks like that.